So we're just going to very quickly look at the principles of warm roofs now. Now, I'm just going to draw a typical flat warm roof, actually, to explain the concept. So here's a building. Concrete. Let's say this is a concrete flat roof. And in a very basic kind of warm roof construction, you would simply have a vapor barrier put down on top of the concrete. And that would often be a liquid applied vapor barrier. You would have your insulation, which would be often a rigid insulation, foamed insulation. And then very simply, a waterproof membrane on the top. That would be your sort of very most basic warm roof. These gaps that I'm drawing don't really exist. Okay, this construction would all be squashed together. And the basic principle is that the moisture you create in the building and the moisture that is coming out of the concrete, it simply can't get into the insulation because you have a continuous vapor barrier which is stopping that moisture permeating into the insulation. Now, the reason you have to stop that is because you have no ventilation layer here. So there's not really any way for that moisture, if any moisture was to get into that insulation, it can't get out. Okay, you might have a sort of torch applied liquid membrane on top of that. You might have a single ply membrane, a very thick rubber type membrane, and that simply will not breathe. It will not let moisture move through it. But it's fine because you always would have this very robust vapor barrier just below your insulation, which, as I say, is often liquid applied, and it will seal all the gaps. Now, if we look at that in a pitched roof example, so I've got this example, which is also a hidden gutter example. So if we look at so this is the building here. It's a housing block. It's a very simple building. It's rendered. It's got a standing seam metal roof, which looks like zinc or stainless steel to me, and it's got hidden gutters. Okay, look at the other image here. No gutters. Okay, architect obviously didn't want to see the gutters. I mean, they've also gone for, if you look at the detailing of the windows, we've got flush fixed glass. There's no sort of articulation of the window. They obviously wanted a very kind of pure, clean aesthetic on that building. Okay, so let's have a little look at that roof construction. Right, so let me just start by drawing the wall, which is, it's 400mm thick aerated blockwork. Yeah. So what they're doing here is they're using very insulative blockwork, concrete blockwork, as the wall construction. So that blockwork, it will perform very well thermally, and it will perform very well structurally. And I can imagine what they're doing here is, because they want to minimize cost and they want to keep things simple, the basic structure is the insulation. So it's a single skin of blocks that thick. Really straightforward. It must be really, really quick to build. And what they have done on top of that, sorry, on the face of that, is they then have put an insulated render system onto it. These are proprietary systems nowadays. So these are through colored renders. You're not painting them. The color is all the way through that render. So if you chip it, it doesn't expose white underneath it. The systems come typically with a sort of 100mm insulation. They're completely watertight, these renders. So they're very good, very good systems, very good products. You have to be careful about them at ground level, because if you kick it, you can break it. Okay. That's the basic wall construction of this building. And now let's look at the head of it. Okay, so we've actually got a concrete ring beam at the top. What they've done is, as you go up the building, they've managed to thin the blockwork down. Okay, so I'm just going to break through now. So we've got 400mm of blockwork on the lower levels, and then as you get higher up the building, it reduces down to about, looks like 240 of the same idea, insulated, aerated concrete blockwork. Okay, and again, that insulation and render continues through. Okay. So there's the basic wall, and it's plastered on the inside. Okay. And it looks like what they've got is they have cast a concrete ring beam along the top just to stabilize everything, hold it all together, and give them a good bearing so they can put their rafters on it without the sort of risk of pushing those top blocks off. So that's a bit of in situ cast, probably reinforced concrete. Okay. And that then allows them to bear their timber rafters off that. And it's not terribly clear on the detail I'm referring to, but it looks like what they've done is they're using those rafters to help create that hidden gutter that they wanted. So it looks kind of like something like that. That looks like the kind of shape of the timber rafters. And probably, although it's not shown here, probably there's a steel bracket, I would have thought, on here. And that will be bolted down very, very securely into the concrete, and then it lets them get lots of fixings into these timbers to make sure that they just stay in place. So there's the basic structure, and I've not quite left enough room here. Right, bear with me. They've left some space for this hidden gutter, so let me just amend that. Because what we know is that the render continues all the way through. So in here, we need to carve out some space for that hidden gutter. And what they've actually done is they've stopped the rafters slightly short, a bit like that. Okay. Right. So the roof build-up here, you've got, again, they've used OSB. So let's just put that top layer of orient strand board on there. Okay, 22 mil. And have they used the same? Interesting. Okay. What they've actually done here is they have stapled a vapor barrier to the underside of the rafters and irons. And then all they've done is they've put timber battens on here and plasterboard. So presumably the timber battens are there either to just level out the ceiling, or maybe they are just creating a small wiring zone in there, quite probably producing a wiring zone. That internal plaster can then be joined, so we have a seamless plastered finish inside. Okay, just waiting for my Tipex to dry. Nearly there. Okay, that steel bracket I've done looks a bit wrong now because I've chopped the end off it. Okay, I'm sure they would have put it in the middle, but you get the idea. So this is how they're creating their gutter zone. They've had to create the space for it, because in a more conventional roof, you couldn't have done that, because you would have brought your rafters all the way over, and you'd be looking to put your gutter on here. But because we don't want to do that, we have to bring that gutter back inside. Okay, let's just finish off this roof. As before, lots of insulation fills the roof cavity. Okay. Now the difference with this roof, because this is a warm roof, essentially, if this is a cold roof, we would now be looking to create a good-sized ventilation zone below our sheet metal roof covering to let lots of ventilation. But we're not doing that here. This is a warm roof. And what they have got here is actually it's sheet zinc. Yeah. So all they've got, they have a separating layer, which is just a kind of building paper, which goes on top of the OSB. That will serve to keep that OSB dry while they're on site. So it's just when it's raining, it's stopping everything getting soaked. But it's not really the waterproofing layer. And then, I can't draw it yet because we've got the gutter to come, but their sheet zinc roof is sat straight on top of that separating layer. So there's no ventilation zone created. So they're relying on the vapor barrier here, stopping the moisture from getting into that insulation. Once that moisture is in the insulation, it really is going to struggle to get out, because that sheet zinc is laid directly on top. So although there'll be a little bit of air gap under that sheet zinc, it's not going to be adequate to dry that construction. Okay, so the gutter, okay, is, yep, right. So what they've done to make the gutter, first of all, just draw, that's That dotted line is the eaves that we want to create. So we've got to get our gutter in here. They had a sheet zinc, folded zinc gutter. In here, and that's just floating the way I've drawn it at the moment. And the sheet zinc roof, let's draw it with that pen. Is then lapped down into that gutter. Okay. And as before, that's a standing seam roof. So you'd see those vertical standing seams going up the roof, and the roofing contractors are very clever. They have ways of flattening out the seams. If you want to take that roof and bend it down into a gutter, they can flatten it for you and curve it. They're skilled people normally, so that for them that's all quite easy. And then what they've done to finish off this sort of flush appearance is they've put a zinc coping over that, over the front face of the render. Okay. So we've got that kind of flush aesthetic that we were looking for. This gutter is still floating, and in fact all that they've done is they've just used lots of bits of OSB. Finish this off, and I've not drawn it all that accurately, but there's some bits of timber in here. To sit the gutter on, the insulation comes up. Something like that. There's a piece of plywood under there, and I'm assuming that there would be a stop bead here to continue that render up to. Okay, so you see the kind of two differences there. One is the hidden gutter, and the other one is the warm roof idea. Now, the benefit of the warm roof is we are achieving a much thinner roof build-up. Given that we've got accommodation in the roof space here, that's potentially quite important. The problems with the hidden gutter, if that gutter was to get blocked and nobody maintained it, you could imagine what would happen with water overflowing. And you would have water overflowing here, flowing down, the top of your wall, into your insulation. So it does come, with risks. There's a very good reason why for 4,000 years we put gutters on the outside of buildings. Okay, it's only in the last 20 years that we thought that was a bad idea. Okay, but no, I mean, it can look really good having those hidden gutters. Okay, what I would suggest with this, I would have gone for a much bigger gutter for a start. I've drawn that it looks about right as per the detail. And that gutter looks about maybe 150 millimeters wide. I think I would have gone for something a bit more substantial, so you could get up there, get your arm in, something that would have a lot of capacity. You can then put leaf guards in to try and keep them clear of debris. Okay. Any questions on that? All right. Yep. Well, yeah. Yeah. Well, you can sometimes if I draw a plan version of this, supposing that's your thick wall, you know, one thing you might do is create a recess in your wall, which would allow you to hide a downpipe, but you've still got the issue that it's inaccessible. So your other option is to run that downpipe inside the building and run it down a riser, which can be okay because you can open the riser doors, get into it, maintain it. But as you can see from here, you've got to bring that outlet from the gutter, and you've got to somehow bring it into the building. So it's quite complex detail. Yeah, that's tricky. That is tricky. So, yeah. I mean, I think for, what I would say for student projects, if you were exploring that technology and you were looking at hidden gutters, we would not be expecting you to have resolved the downpipes. I think if you resolve this kind of level of detail, we'd say, well, that's fine. You're not doing a full building regulations submission, so we'd accept that. Sorry, this question first.
I was wondering, why would you choose one over the other apart from
the warm or the cold?
Yeah, is there scenarios where one is better than the other?
I mean, generally, a cold roof is better, really, because you're getting that good ventilation. Cold roof is what we've been doing for thousands of years, basically. Works really well. You've got that certainty that you can ventilate out. Even to the extent, if I lost it, just draw again. If we go back to a sort of typical UK dwelling, with the roof here and maybe some insulation here, you can even have these roofs, you can even have a leaky roof, because you've got so much ventilation that it will dry itself out. So you can even go to a roof where you don't have a roofing felt, and the odd bit of moisture might get blown through that roof, but it will get dried out. So strictly speaking, they're better, but they take more depth. Constructionally, they're more complex. More and more now, because people want to occupy the roof, they want something simpler, and so they're kind of moving away from it. Now, I should just draw you what's kind of a hybrid. I'll just do this very quickly. What we typically get now in the UK, in a typical sort of terrace house, is because, as you know, people are now starting to build into their, well, they're not starting to, people are now building into the attics in most terrace houses. Whether they were designed for it or not, people are now building into it. So there's your typical detail in a sort of Sheffield terrace, something like that. And traditionally, these would have had either no insulation, or you would have had some insulation down here. Okay. What we are doing now is we're putting insulation in the space between the rafters, like this. Okay. And the reason I say we're ending up with a kind of a hybrid is because under the building regulations, you need to keep at least 50 millimeters gap here, above your insulation and below your slates or your tiles. So we are maintaining something of a ventilation zone. So it's kind of a cold roof, but it's not the sort of full cold roof with a substantial ventilation route. And often these roofs, we have to supplement them by putting in ventilators periodically to get extra ventilation in there. So it's not really a true warm roof either, because there is some ventilation, which is why I call it a kind of a hybrid. Okay, it's more like a cold roof than a warm roof, I suppose. But that's what we're commonly seeing now in the UK. Okay, so there's a question there, and I'll come back to you. Oh, okay. I would be looking for 100 millimeters. With the 50 mil, under the building regulations, you normally have to supplement it with these ventilators in the roof. That's why when you see a Sheffield terrace, you see these little plastic things dotted about the roof. They're little ventilators to just improve that ventilation, because really the 50 mil, it's not quite adequate, and then if one builder just pushes that insulation too far, you've got no gap. Or if that insulation actually touches the underside of the roofing membrane, you can get condensation there. Okay, I think we'll call it there. Okay, so we've done a warm roof, we've done a cold roof, we've done a hidden gutter, and we've done an exposed gutter. Now, if you want more, if you just get Detail Magazine roof construction, or timber construction, or pitched roof construction, loads and loads. Or get the Berkhauser pitched roof construction manual. Excellent book. Okay, loads more examples in there. Any more questions?